If you have a dream game but you don't know how to code, don't worry. In this video I will teach you all the core concepts you need to learn to make games, and by the end of this video you will be a god tier programmer. And if you got slightly offended I called you a dummy in the title, well, I'm sorry. Lesson 1. Programming is problem solving. That means programming is not a skill you can learn passively. You gotta do stuff. First of all, you need a clear goal, like a clear thing you want to program. Then you're gonna try to do it on your own. And when you find problems, you try to solve them on your own. Then when you inevitably fail, you'll Google the hell out of it. Lesson 2. You can transfer your skills. Like I said, programming is about problem solving. It's not about learning a specific language, which is why people typically start with a visual tool like Scratch. But we're not gonna do that today. We're actually gonna go straight to Godot. Lesson 3. Every language has a context. Before we dive into Godot, I need to explain this. We're gonna use GDScript, which is a language that was created for Godot and only for Godot. I say this because GDScript has a lot of quirks that only make sense within the context of Godot. You should approach GDScript like JavaScript, for example. JavaScript only makes sense under the context of browsers, right? So just keep the context in mind. With all that being said, let's code. Lesson 4. Preparing Godot. Welcome to Godot. Remember, this is the context. And Godot is a really powerful context. It does a lot of the work for us. So we're going to spend a lot of our time here instead of coding. The first thing you got to do is create a 2D scene. And there you go, we have created a scene. You can actually double click this and change its name. Let's name it main. Press Ctrl S to save it, and you can see it's called main.tscn, which is a Godot scene. Save it and it's saved to our file system. This is basically all the files in our project. And this is the current scene, and this is the hierarchy of nodes. And nodes are basically Godot's building blocks. I'm going to explain more in a bit. If you click run, you're going to see Godot asks for you to define a scene as the main scene. What is the main scene? It's the entry point for the program. Any other programming language needs an entry point as well. It's where your code starts, it's where you put everything together. It's basically the most important thing in your game. So just select the current scene as the main scene. And there you go. This is running right now. This is our game. Obviously it's empty, but we're gonna start creating. Alright, as you can see, I have imported some assets. And we can just drag these assets in. So I can drag in the terrain, the apple, and the character. I can click on the terrain and drag it to put it in a better position. By the way, this giant rectangle here is the screen. If I click on play, there they are. Okay, now I can scale things. So we can click on the character, transform, scale. I'm going to scale by 2. I'm going to do the same thing to the apple. If you notice everything is a little blurry, that's because Godot uses filtering by default. So let's go to texture, filter, and change it to nearest. We can do the same thing to the apple. If you're wondering, yes, you can do this for the whole game, going to project settings, but I'm not gonna get into that. Okay, if we click play now, looks way better, but as you can see, everything is still static. And that, my friends, is where programming comes in. Lesson 5. The programming. Alright, let's get to the programming. Oh, by the way, if you're wondering how I'm doing this, I just hold down the mouse wheel to move around, and then scroll to zoom in. That's basically all you need. First of all, for the character, for the player, you're gonna need a character body 2D. You're gonna change the order here. The character sprite should be a child of the character body. You can double click to name it again. I'm gonna name this character Sprite for clarity. I'm gonna name all the sprites Sprite, just so we know. You can see by the icon that these are different types of nodes. Yes, a sprite is a sprite 2D node, and a character body is a character body node. The character body needs a collision shape. It even tells you this in the warning here. So we're gonna create a collision shape. The shape, if you click on it, you're gonna see its properties on the inspector, and you can give it a rectangle shape, or actually a capsule shape would be better. Perfect. Now you're probably wondering, how the heck am I supposed to know all this? And this is a good moment to teach you the concept that sometimes you can only learn things by exposure. You can only know this by reading the documentation or watching a tutorial or reading about it online in some way. This is not something you can guess. No, you have to get exposure to this, and this is why in the beginning you're going to watch videos like this. You're going to watch tutorials, introductory courses and all that, so you understand how Godot works. Okay, the character body by itself does nothing. We need to give it a script. And this is how coding works in Godot. You assign scripts to certain nodes. So click on this icon. I'm going to name this player.gd. You can choose a language. We only have GD script in this case. Don't change this. And let's use this template. Click on create and you can see our script file here. You can also notice that we have changed the workspace from 2D to script, but you can go back whenever you want. Here is a bunch of code that, don't worry, I am going to explain, but right now, click on play. Yes, our character falls. Because our character has a collision, the floor or the terrain does not. So how do we give the terrain collision? Basically, you have to create a static body. Again, this is something you have to learn. It's not something you can guess. Just drag the sprite here. Another thing you can learn is that when you have a sprite, you can actually create a collision automatically by clicking this. Just create, and there you go. That's our collision. If you play now, yeah, now the floor has collision. Big surprise. You can also notice that when you use the arrow keys, the character moves around. And if you press the spacebar, you jump. How awesome is that? Now what's making the character move is the script. All of this is making the character move. Okay, what we have in front of us is a default template provided by Godot to make the character move. These values are variables. They are data containers and they provide a name so you can reuse this data later. As you can see, speed is used here and here, and you can change this variable to anything you want. I can change this to 800, for example, and if I play the game, I am going to see the change. If I change this to 2000, yeah, I'm going to see the change. Let's leave it at 300. Jump velocity is the same thing. We're using it here. We can change it to anything we want. We can change this to 2000 as well. Yeah, really high. I'm gonna leave this at 400. Gravity, as you can see, is using the var keyword. This is to create variables that can be changed later. Const means you cannot change the value later. This is forever going to be minus 400 unless you change it here. Otherwise, anywhere else you cannot change it. Gravity, I could just say gravity equals something here, right? Because it's a var. I can't do the same thing to jump velocity or speed because they are constants. What's happening here? Godot is just taking a default value from the settings. This is not beginner friendly though. It's basically just 980 as in 9.8 as in the value of gravity in real life. So 980 is the gravity, and now if I play the game, you can see everything still works the same. It was just 980, but Godot was getting it from a much more difficult source. That's what I'm trying to say. So yeah, 980 is gravity, 980 here in this case. Next up, we have functions. Func as in functions. This is a default function in Godot, and this is just something you're gonna have to get used to. It's the default functions. In programming, you don't create everything. A lot of the stuff is already there for you. Physics process is gonna run 60 times a second. Everything that's in here is gonna run 60 times a second. And you can tell that it's a part of the function because of the indentation. This is not a part of the function. This is. Just pay attention to the spaces, like the tabs, right? Now let's go line by line. All of this is running 60 times a second. Yes, it's really fast. If is an if statement. It's only going to run this line of code if the condition is met. The condition here is not on floor. Not is just to do the opposite of this, which in this case is on floor. This is another built-in function, okay? This is going to return a value. This is going to be either true or false. It's called a Boolean value. I'm sure you've heard of it before. It's either true or false. It's a binary value, 0 or 1. So if it's not true, do this. This line of code is basically taking the velocity of movement of the player, the movement velocity here, in the y-axis. So you basically have x-axis, the red line here, the red arrow, I mean, for the horizontal axis, and the green arrow y-axis for the vertical axis. So you're gonna apply gravity to the vertical axis. So basically, you can read this as if the player is not on the floor, apply gravity. Delta, you can ignore for now, okay? One day you're gonna learn this, probably soon, but it's not too complicated, don't worry. I just don't think it's relevant for this lesson. This is another if statement, and this is getting Godot's default input system. So if this action here is just pressed, and action is just a generic name, and you can define any key for this generic name. We're going to talk about this in a second. And operator means that both conditions must be met. So if the player is pressing this action and is on the floor, you take the velocity and apply the jump velocity. So basically, if the player is on the floor and they press the space bar, jump. This is what this line is doing. We're going to talk about input in just a second. This part of the code handles movement, but it's not very beginning friendly, so we're going to do our own way. If we save this, you're going to notice that we can no longer move, but we can still jump. This is pretty much the way you handle jump and gravity in most games. I don't have anything to complain about this, but now let's worry about making our own movement. Alright, before we make our own movement, let's talk about actions, shall we? UI accept is a built-in action in Godot, and it's tied to the spacebar and some other keys. To create our own, go to Project, Project Settings, Input Map. You can show the built-in actions, the ones we were seeing, like UI accept, select. This one was UI accept, and you can see that enter and space were both UI accept. So if we play the game and press enter, we can still jump. This is not supposed to be used for games. This is supposed to be used for UI. So let's hide the built-in actions and create our own. Let's create a jump action. So you can give it any name you want. And here you're going to add a key. You can add keyboard keys, mouse buttons, and gamepad and joypad buttons. You can also obviously click the spacebar. And there you go. This is the spacebar being assigned the jump. So now we just say jump in here. And now we can still jump by pressing the spacebar, but enter no longer works. And if you happen to have a gamepad, you can already put some buttons here. So joypad buttons. Go to bottom action, Sony Cross, Xbox A, Nintendo B. So basically jump when you press A on the Xbox gamepad, or cross on the Sony gamepad and all that. So yeah, this is very easy to handle. This is how you handle input. This is your basically your keybinds for the game. I'm already gonna create move up, move down, move left, move right. W, A, S, or A, actually A is here, and D, okay, all good. You can also include the arrow keys, but remember last time we only had the arrow keys. What did I press here? Up, down, left, and right. And you can also include gamepad if you want. Just go to D-pad up, down, or even in the axis, you can use the sticks here. I'm not going to do that. That was just for demonstration. Now we have our own actions. And the way we do this is just if input dot is action just pressed. Just pressed is only going to register once when it's just pressed, and pressed is going to register holding as well. So if the player is holding to the left, we're going to take the velocity dot x. Remember, we have the x and y axis, and we're going to do plus equals, which means we're just adding values here, and we're just going to add the speed. Remember the speed? We're just going to add 300 for each frame the player is holding the left. Also, since it's going to the left, it's probably the opposite of adding, it's just subtracting. We can do the same thing. If input dot is action pressed, remember for holding, move right, velocity dot x plus equals speed. And I just realized we're not going to use up and down. I'm just so used to creating up and down, but yeah, we're not going to use them. We're just going to jump if we have to go up and fall if we have to go down. Anyway, ignore me, just focus here on this code. Let's see. Okay, yeah, sure, it's working. It's going really fast, but it's working. This is how it should look. I am stupid, I'm sorry. It's minus speed. There is no delta. It's just equals. Equals minus speed equals speed. I'm sorry, I'm stupid. If the player is pressing A, move to the left. If not, and is moving to the right, move to the right. If none of these, make it 0. Yeah, and now everything works. Yay. And you can jump as well. And just to make you understand that when we want to make the character move, you just simply change the velocity, okay? And this is the final thing. It's move and slide. And the only thing it's doing is moving the character for real. We can change the velocity all we want. If we don't have this, nothing works. So just make sure you have this at the end of your physics function, and everything shall work just fine. Okay, now that we can move around, let's add some more interactions. So, what if I want to give the player the ability to take some apples? So let's just create an apples variable here in the player script. Let's make it 0 by default. So this is just going to store the number of apples the player has. Now we can create our own function. So just say func, like this, add apple. So just add apple, and here we're just going to say apples equals apples plus 1, or for short, plus equals 1. Okay, so that's all we need for now. And if you're wondering, why did we do this? That's because we're going to call this function somewhere else in another script we're going to create in just a second. For now, we can do something really fun in Godot, which is just print. Print is a function as well that is built into Godot. So just print apples. So what does this do? Well, when you run the game, you're going to see 0 here, right? It's just going to print into the console here, into this small console window we have. It's printing a lot, as you can see. Basically, it's printing apples 60 times a second, and it's 0 now. But what if we just add apples right after we print? So we're calling our own function here, adding an apple, which is just basically going to copy paste all the code that's in here, and in this case it's just one line, but it could be more, and paste it here. So it's going to add one apple each frame, and basically 60 times a second, right? So if you click run the game, look, we are adding 60 apples per second basically. So that's cool. We're calling print and we're creating our own function. And don't worry, we're going to do more stuff with this later. Okay, so to make our apples interactive, we have to use an area. An area is a node that just simply detects when something enters and exits it. An area also needs a collision, and I'm going to do the same thing I did earlier. I'm going to put the apple sprite here. I'm going to call this apple, and we're going to give it a collision shape. Since the apple is like very minimalistic. Oh, the apple is here, by the way. If it's not, remember to go to the sprite, transform, and reset it to 0. Because now when we move the apple, we don't want to move the sprite, we want to move the area itself. For the collision, I'm just going to give it a little circle shape that kind of matches the apple. Okay, so this area is now capable of detecting when bodies, like a character body or a static body, enters it. Okay, now we're going to create a script for the apple. So let's just do this and call it apple.gd. I'm just going to do it lowercase here. Don't mess with anything else. And it's empty right now. Okay, because this is a script that we're going to create ourselves. Like I said, an area can detect when a body enters or exits it, and it does so using signals. So if you click on the apple, go to the node tab right after the inspector, you're going to see the signals for any node. Other nodes have signals as well, but let's go to the apple, see which signals it has. So body entered and body exited, but we're just going to use body entered. You can double click, connect it to a script. So let's connect it to our own script here, the apple script, connect, and you're going to see this little icon here, meaning that this function is called automatically when a body enters. Really cool, right? This is a Godot functionality. Like I said, it's exclusive to GDScript, so this is one of the quirks I was talking about earlier. We can replace this with anything we want, and I'm just going to call queue_free when here. And queue_free is a function that basically deletes the apple. But first, you can see we have access to the body here, the body that entered. Which means this is straight access to the player here, meaning we can call body, which is the player, remember, .add apple. Remember, this is a function we created. So outside of the player, we can have access to it because of this little thing. Otherwise we wouldn't. If we tried to call just add apple, it wouldn't work because it's in the player, it's a different context. So here, it works now. Because we're going to the player, accessing its properties, and calling the function addApple that's within the player script, right? Cool. Now, what if we go to the player here and just call print inside of here, actually after, and play the game. Let's just remember to drag the apple back down here. I forgot to delete this. Okay, delete it. Now play the game. And now when we collide with the apple, it gets deleted and it adds it to the player. Now what if we want more apples? We could just like copy paste this a bunch of times. But this isn't right, my friends. Because then if we wanted to change one apple, we would have to change every single apple. That's why Godot has scenes. We can right click here. We can click on Save Branch as Scene. And we can save it as apple.tsc. And I already did this once, don't worry, I'm just gonna overwrite it. So now apple is a scene. We can click this icon to open it in another tab. So this is the apple scene. We can switch between the apple scene and the main scene. And now we can actually take the scene here and start dragging and dropping it all over the scene as much as we like to. And if I make a change to one apple, for example, if I want to make it bigger, and save this scene, you're going to see all the apples are bigger now. Awesome, everything works. All the apples are adding apples, as you can see here. Cool. Pretty awesome, right? Now let's just create some UI for this. To do so, we just need a canvas layer, which is basically gonna create another canvas that is separate from our game world. So it's gonna be on top of everything, and if the camera moves, the layer stays on place. Let's just give this a label, which is text. Let's make it 0 by default. And we can change the font by going to theme, override, font, and change the font, but I'm just gonna change the font size here to something like 40. As you can see, there it is. Now we can anchor it to the bottom right of the screen. There it is. If I play the game now, we can see the number there, but it's not tied to the player yet. It's not tied to the apples. How do we do this? Very simple, my friends. Go to the player script again, and we need a reference to this object. We need a reference to this label, this specific label. How do we do this? The export tag. Use export var label. And then what you're gonna do is you're gonna give it a type using the colon, type label. It's not the equal sign, it's the colon, label, to give it a type. Okay, so it can't be a number, can't be text, can't be another object, can only be an object of type label. It could be another label if we created another one. So it would be nice to just say apple label, just to make sure. And there it is. So now we can click on the character body, and in the inspector you can see apple label shows up, and we can assign it to the label. And since we gave it a type, it doesn't accept anything else, only the label. Now we can change, instead of doing print, we actually do apple label dot text. We're accessing the text from this label, and we're gonna set it to apples. Now you're gonna notice an error when I try to pick an apple, that we can't turn an integer into text, right? So we have to convert this number into text first, and for that we use str, which is a function from Godot. Take this and put it in here. So we're going to turn the number of apples into a text and pass it to the label text. And there you can see the UI updating. We currently have 7 apples, and that's correct. Awesome, now everything is working, my friends. Okay guys, we have created the character, we have learned about variables, functions, references, signals, all this stuff that are core to game development. Where to go from here? Well, finish the game. You know, make those collecting games, just make the apples fall and everything. And most importantly, check out Brilliant. So I'm not gonna lie, Brilliant might be the best way to learn programming logic. It might be the best way for you to train your problem-solving skills and think like a programmer. Brilliant is where you learn by doing. They have interactive lessons in math, data analysis, programming, which is really good for us, and even AI. And the main difference about Brilliant, of course, is that you'll get hands-on, you will solve problems, okay? This is really, really helpful. And the classes are fun, honestly, even the math ones, I take them all the time. So learn a little every day with Brilliant, and if you don't believe me, don't worry, they will give you 30 days for free. 30 days for free and 20% off the annual premium subscription. Click the link in the description, which is brilliant.org/Freddy. Thank you so much, Brilliant, for sponsoring today's video. Yeah, people, catch you on the flip-flop. Bye-bye.